Division of polynomials. Before you work through this video, you will need to know how to add, subtract, and multiply polynomials. If necessary, you should refer to the following video, which covers this topic. Thanks for watching this video, and don't forget to like, subscribe to the channel, and activate the notifications. It's very important to the continuity of this channel. Let us start dividing a polynomial by a monomial. To divide a polynomial by a monomial, separately divide each term of the polynomial by the monomial and add the quotient of each operation to get the answer. Let's try one example. When dividing a polynomial by a monomial, divide each term of the polynomial by the monomial. Remember to use the quotient rule for exponents. The process of dividing polynomials is just similar to dividing integers or numbers using the long division method. So, before undertaking the division of polynomials, it's best to consider the method for long division of integers. Let's divide 842 by 15. The dividend is the number on the right side under the line. It represents the amount being divided. The divisor is the number on the left. It's the one doing the dividing. The quotient is written above the over bar on top of the dividend. The remainder is the number on the bottom right. Let's see how the long division works. Dividing 84 by 15, we get 5 and some extra. This gives us the first term of the quotient. We now multiply 15 by 5. We get 75. Subtracting 75 from 84 gives 9. Bring down the number 2. Dividing 92 by 15, we get 6 and some extra. We now multiply 15 by 6. We get 90. Subtracting 90 from 92 gives 2. Since all the digits of the dividend were brought down, the remainder is found. The result of the long division algorithm may be expressed as dividend equals divisor times quotient plus remainder. Let's check our answer. To divide polynomials, we use long division as follows. If p of x and d of x are polynomials, with d of x different of 0, then there exist unique polynomials q of x and r of x, where r of x is either 0 or of degree less than the degree of d of x, such that the process of dividing polynomials is just similar to dividing integers. So let's see how the long division works for dividing polynomials. Pay attention in this example. Here are the steps required for dividing polynomials. Arrange both the divisor and dividend in descending order of their degrees. If any terms are missing, use a 0 to fill in the missing term. This will help with the spacing. Divide the first term of the dividend by the first term of the divisor to obtain the first term of the quotient. That is, we divide x cubed by x squared, and we get x. This gives us the first term of the quotient. So we will put an x on top of the division symbol, right above the x cubed inside. We now multiply the divisor by the first term of the quotient. we put the result directly below the dividend. We can now subtract the product from the dividend. We bring down the next term. We create a new polynomial. We treat this new polynomial as a dividend as the same steps are repeated until the remainder becomes 0 or its degree becomes less than that of the divisor. To get the next term of the quotient, we divide the first term of the new dividend by the first term of the divisor. That is, we divide minus 3x squared by x squared. Thus, minus 3 is the second term in the quotient. We multiply the divisor by minus 3 and subtract the product from the dividend. The process is complete at this point. Notice there are no more terms to bring down. We write the final answer as follows. Dividend equals divisor times quotient plus remainder. Let's see another example. Both polynomials should have the higher order terms first. Make sure the polynomial is written in descending order. Do not forget to use the number 0 to fill in the missing terms. Divide the first term of the dividend by the first term of divisor to obtain the first term of the quotient. Find the product of all the terms of the divisor and by the first term quotient and subtract the answer from the dividend. Bring down the next terms. We create a new polynomial. This new polynomial is treated as the new dividend. We repeat the process. Divide the first term of the dividend by the first term of divisor to obtain the second term of the quotient. Find the product of all the terms of the divisor and by the second term quotient and subtract the answer from the dividend and bring down the next terms. We repeat the process again until the remainder becomes 0 or its degree becomes less than that of the divisor. At this point, there are no terms to bring down. The degree of the remainder is less than that of the divisor. So we get the answer. There are two methods in mathematics for dividing polynomials, the long division and the synthetic method. The synthetic method is a shortcut way to divide polynomials when the divisor is of the form x plus or minus k, that is, polynomial of degree 1, and the leading coefficient must be 1. I will explain how to perform the synthetic division in the next example. We begin by drawing the division box. To set up the problem, first, set the divisor equal to 0 to find the number to put in the division box on the left. Next, write the coefficients of the dividend on the right, and if any terms are missing, you must use a 0 to fill in the missing term. Once the problem is set up correctly, bring down the leading coefficient to the bottom row. Multiply 3 by the value just written on the bottom row. In this case, we multiply 3 by 2. And we place this value right beneath the next coefficient in the dividend. Add the two numbers together and write the result on the line below next to number 2. We repeat this process. We multiply minus 1 by 3, and we place this value right beneath the next coefficient in the dividend. Add the two numbers together and write the result on the line below next to the number minus 1. We repeat this process. We multiply minus 3 by 3, and we place this value right beneath the next coefficient in the dividend. Add the two numbers together and write the result on the line below next to the number minus 3. There is no more number in the dividend to continue the process. The numbers in the last row make up your coefficients of the quotient as well as the remainder. The final value on the right is the remainder. The other numbers are the coefficients, in descending order, of a polynomial whose degree is 1 less than that of the dividend. Working right to left, the next number is your constant. The next is the coefficient for x. The next is the coefficient for x squared. Pay attention in the next example. First, set the divisor equal to 0 to find the number to put in the division box on the left. Next, write the coefficients of the dividend on the right, and if any terms are missing, you must use a 0 to fill in the missing terms. Bring down the leading coefficient to the bottom row. Multiply minus 2 by the value just written on the bottom row. In this case, we multiply minus 2 by 3. And we place this value right beneath the next coefficient in the dividend. Add the two numbers together and write the result on the line below next to the number 3. We repeat this process until there is no more number in the dividend to continue the process. The final value on the right is the remainder. The other numbers are the coefficients, in descending order, of a polynomial whose degree is 1 less than that of the dividend. Pay attention.